Good afternoon, students. Okay, we are going to discuss about the experimental study of photoelectric effect, or it is also called Lenard's experiment. Okay, so this is the study on the photoelectric effect by which we can learn about the theory of photoelectric effect. Okay, so before going to start here, तो फोटोइलेक्ट्रिक पढ़ने के लिए तो बहुत सारे साइंटिस्ट क्या किए वहां पे दे विल इन्वेस्टिगेट सम एक्सपेरिमेंटल फिनोमेना सो एज लाइक हर्ज एक्सपेरिमेंट राइट सो हलवाज एंड हर्ज एक्सपेरिमेंट दे आर आल्सो परफॉर्म इलेक्ट्रोमैग्नेटिक रेडिएशन व्हेन दे आर in the different conditions. Okay, so this is not for your syllabus. Okay, we are going to have only the Lenard's experiment that is based on photoelectric effect. Okay, तो जो भी रहेगा यहाँ पे है photoelectric experiment के बारे में हम पढ़ना है. तो देखो experimental study of photoelectric effect is done by Lenard's scientist by name Lenard. He has given some construction of experiment and working. So based on this working condition, we have some observations regarding the Lenard's experiment. Okay, तो हम पहले क्या पढ़ना है यहाँ पे एक्सपेरिमेंट कैसा सेटअप करें सो है. Okay, look at the figure here. So here the window is opening for light radiation. Okay, so this is ultraviolet radiations which will incident on the this window. ओके तो यहाँ पे थोड़ा सा ओपनिंग रहेगा. वो ओपनिंग में क्या है हमारा आपको क्वार्ट्ज विंडो रहेगा. सो दे विल फिल्टर विद सम रेज अल्ट्रावायलेट रेज एंड विजिबल रेज ऑल दोस थिंग्स. सो दे विल इंसिडेंट ऑन द कैथोड. ओके तो उसके सामने क्या रहेगा कैथोड. दिस इज एनक्लोज कैथोड एंड एनोड बोथ आर एनक्लोज इन ए इवैक्यूएटेड ट्यूब. ओके व्हिच इज आल्सो connected to positive terminal of battery and which is also connected to microammeter. Positive this is also have high tension battery. So तो यहाँ पे देखना है एनोड is connected to this positive. Okay, so यहाँ पे high tension मतलब ये positive रहेगा. Okay, so यहाँ पे क्या है, so this is connected to negative. Next again positive connected to this voltmeter. Next cathode. Okay, so कैसा लिखना है, it consists of evacuated tube which is having enclosed in a one tube. In this one cathode is anode placed in front of anode which is also connected to rheostat, and so rheostat is connected to the battery. Okay, so इसके बारे में हम देखना है. Okay, so this is positive terminal is connected to rheostat. This positive terminal is connected to anode. तो यहाँ पे क्या रहेगा नेगेटिव रहेगा. तो नेगेटिव is connected to negative. Next positive is connected to cathode. Okay, this is the experimental setup of this Lenard experiment. Okay, so देखो cathode क्या रहेगा. When all the incident light radiations fall on the cathode surface, cathode is something but metal surface. So यहाँ पे क्या रहेगा पॉलिश्ड रहेगा. पॉलिश्ड रहने के they will this surface has polished by some metallic surface. So as like zinc, magnesium, like this coated surface. So ये क्या करेगा. Okay, so when there is no light of incident intensity of light. So यहाँ पे जितना लाइट नहीं आया मतलब वहां पे क्या है, so there is no ejection of electrons here. तो ejection of electrons नहीं होने देता. तो इसका मतलब है when there is no light incident on cathode surface, there is no deflection in the micrometer. Hence there is no current in the circuit. तो flow अंदर के क्या है सर्किट के अंदर flow of current नहीं होता. So when there is many incidents of UV radiations, तो जितना हमारे को radiations fall होने के बाद if consider one photon fall on this cathode surface, one electron will be rejected out. Okay, so as the intensity of this increases, there is a flow of electrons. Due to this flow, so electron charge and positive anode, so they will get attracted here. So होने के बाद क्या आएगा हमारे को माइक्रोमीटर के अंदर करंट प्रोड्यूस करेगा. That produces the photo current. that is current in the circuit, flow of current in the circuit. So this is some construction and working of this experiment. So according to this, we are going to discuss some observations here. So what are those observations based on this experiment? We have to change the effect of intensity. So जिसका UV rays का intensity change करना है, or we can change the frequency of this radiation. We can have the effect of potential. So this is potential. We have the different frequency change with respect to incident light. Okay, we will going to observe here the things. Okay, so we will study experimental observations of photoelectric effect. So what are the experimental observations here? So जितना हम आपको लाइट फोटोन इंसिडेंट हो रहा है कैथोड के अंदर, तो कैथोड will automatically gives electron. So electron emission, due to electron they will attract here. So there is a photoelectric current produces. So first observation में क्या लिख सकते हैं हम लोग? तो as soon as the incident photons, as soon as light of suitable frequency, falls on this cathode surface, there is a ejection of electrons within the 10 power minus 9 second. Okay, so within the time 10 power minus 9 second के अंदर क्या हो रहा हो? Electrons will ejected out. So due to this process, there is a instantaneous process. So this is a instantaneous process. It is an instantaneous process. Okay. So firstly we can observe here, as soon as photons will fall, one photon will fall, one electron will eject out. So many number of photons will fall, they will emit so many electrons here. So due to there is ejection of electrons, there is a process which takes 10 power minus 9 second के अंदर जो होने वाला process है, they will be getting out here. So that is called instantaneous process. Okay. So secondly, okay. तो यहाँ पे क्या करना है? देखो. So this is anode, this is cathode. Okay. So जितना हमारे यहाँ पे incident light यहाँ पे गिरने के बाद there is ejection of electrons. So for example पे 500 photons incident हो रहा है, मतलब there is a 500 electrons will be ejected out here. So जितना 500 photon गिरने के बाद 500 electrons eject हो रहे हैं. So there is a due to flow of current. Okay. So negative to positive attract करेगा. So you will have photoelectric current here. So due to photoelectrons. Okay. So as soon as incident radiation increase होता है, उतने ही क्या हो रहा है? Electrons will get. So due to there is intensity increases. That means photoelectric current increases. Okay. So there you have here. If you want to, okay. So when we apply positive potential to anode, okay. So यहाँ पे positive potential anode को करने के बाद क्या हो रहा है? So there is flow of electric charges due to the incident of these photons. So there is ejection of electrons here. तो यहाँ पे क्या हो रहा है? There is 500 electrons. For example पे बोलो, okay. तो होने के बाद अगर से 500 photons fall हो रहे हैं और metal this surface means 1000 electrons will be ejected out. So due to collection of electrons at the anode, so they will produce current. That current is called photoelectric current. Okay. So as if you want to increase further saturation current, okay. So as you want to increase, if you want to increase saturation current, okay. So therefore, if you increase the positive potential at some particular potential here, okay. So ये एनोड का जो भी पॉजिटिव पोटेंशियल है इंक्रीज करने के बाद क्या होता है? सो एट सम पर्टिकुलर पोटेंशियल, सो देयर इज सम सैचुरेशन करंट. ओके. सो ऑलवेज इट इज गोइंग टू मेंटेन पॉजिटिव पोटेंशियल. ओके. तो पॉजिटिव पोटेंशियल होने के बाद क्या है? एज द इंटेंसिटी ऑफ दिस रेडिएशन इज इंक्रीजेस, photoelectric current also increases. Okay. At particular voltage, voltage, the anode जो भी ये voltage रहेगा at particular voltage there is no increase in the photoelectric current, that it is called at particular voltage the photo current is maximum. Photo current is maximum. It is called saturation current. It is called saturation current. Okay. So further, if you want to increase this saturation current, we have to increase this intensity of radiation. It may be visible light, it may be some ultraviolet radiation. You have to increase the intensity of light. Therefore, you may got some graph here: photo current versus. This is indicated by small I. Therefore, which is proportional to what? Okay, photoelectric current versus that it is intensity. Therefore, I is intensity. So, as intensity increases, photoelectric current also increases. This is the graph for observation of photo current versus intensity here. Okay, तो क्योंकि हम आपको मिला है एनोड के पॉइंट के, तो एनोड मतलब यहाँ पे it is connected to high potential battery. So as if we increase the voltage beyond some particular value, there is a certain if you want to increase saturation current, then we have to increase intensity here. So हम saturation current increase करना है मतलब we got ultimately current here. So if you want to increase some saturation current matlab you have to increase intensity. Okay, so this is second observation here. Okay, so thirdly हम और एक third fourth पढ़ेंगे. Okay, so initially we have applied positive potential to anode. So here apply. Okay, third apply negative potential to anode. Okay, so यहाँ पे positive becomes negative positive को देने का है. So यहाँ पे क्या होगा देखो. So there is anode here. So when the radiation will fall on the cathode surface, there is ejection of electrons. Okay, so ये electrons क्या होते हैं? So there is जो electron यहाँ पे आने के बाद there is for example पे so यहाँ पे नेगेटिव अप्लाई करें. ओके, सो नेगेटिव अप्लाई करें मतलब नेगेटिव और नेगेटिव, सो देयर विल रिपल्शन विल क्रिएट हियर जो रोक सकता है वहां पे. तो क्या होगा, द इलेक्ट्रॉन ऑफ दिस नेगेटिव चार्ज ऑफ दिस दे विल रिपेल देयर टू स्टॉप देयर. सो फॉर एग्जांपल पे 100 में के इलेक्ट्रॉन फोटॉन्स विल फॉल आउट ऑफ फोटो यहाँ पे. सो इजेक्शन कितना हो रहा है मतलब वहां पे 100 हो रहा है समझो. So they will reach here up to some extent 50. Okay, 50 electrons will enter होते हैं वहाँ पे. So again 50 में के और थोड़ा हाई पोटेंशियल अप्लाई करो, फिर से 25 होते हैं. So 25 electrons will come here एनोड के पोजीशन पे, एनोड के ऊपर. नेक्स्ट और थोड़ा पोटेंशियल इंक्रीज करो, फिर से क्या रहता है तो 12 के पास हो जाता है इलेक्ट्रॉन्स. Okay, ऐसे ही if I increase some negative potential to anode, to this anode, for example 5 electron volt के ऊपर आया समझो for example पे, तो there is a stopping, जो इलेक्ट्रॉन है वहां पे स्टॉप होने लगते हैं. So that is called stopping potential. So that potential is called stopping potential. So what is stopping potential here? This is the minimum amount of energy, minimum amount of potential is applied to stop the photoelectrons. That is called stopping potential, or it is also called cut-off potential, or also it is called cut-off potential. Okay, हम इसको और एक बोल सकते हैं cut-off potential. This is stopping potential is denoted by Vs. Okay, so if we increase negative potential to further, so there is a stopping of these electrons. Due to stopping there, photoelectric current becomes zero. So how much you apply the potential to stop the photoelectric current, that is called stopping potential. So this is the minimum amount of energy required, minimum amount of voltage voltage to require to stop the photoelectric effect, there is stopping potential, that is called stopping potential. ओके, सो इसके अंदर हम ए एंड बी हम ग्राफ पढ़ेंगे। तो यहाँ पे देखना है इफेक्ट ऑफ इंटेंसिटी ऑन फ्रीक्वेंसी एंड इफेक्ट ऑफ फ्रीक्वेंसी ऑन इंटेंसिटी। सो फर्स्टली हम पढ़ेंगे इफेक्ट ऑफ इंटेंसिटी एंड फ्रीक्वेंसी। सो when frequency is fixed, then different intensity. So when frequency is same but different intensity. Okay, so graph will be like this. Okay, so when you plot the graph for this observation for frequency same, okay, so for example, if you have here the photoelectric current voltage, okay, तो यहाँ पे potential draw करेंगे। So when you apply potential here, okay, so potential, the photoelectric current will be like this for same frequency but different intensity. But different intensity मतलब क्या रहेगा? mu1 equal to mu2 for same frequency. When you consider some radiation falls on this experimental setup, therefore frequency क्या रहेगा? Same, but different intensity. I1 is greater than I2. You may take I2 is greater than I1. Okay, so the observations will be like this. Okay, so observation में क्या रहेगा? Like this. So different intensity I1 and I2. I1 is I2. So there is photo current I versus potential. This is photo current. Like this, there is variation of potential versus photo current. When you are keeping frequency same but different intensity. So इसके लिए हम क्या करेंगे? This is the same first case. Okay, so this is called third case also. Okay, fourth हम बोल सकते हैं इसको। Okay, so next we will going to discuss the keeping same intensity, different frequency. Okay, so keeping here same. Okay, fourth one. Okay, fifth one, same intensity and different frequency. Okay, different frequency. So when you study this observation here, you may got one graph like this. So यहाँ पे graph आएगा. This is the photo current I versus potential. Okay, so see here, you may got this like this, same intensity. So same intensity मतलब if you consider some more intensities for two different purpose, there will have I1 equal to I2, but different frequency मतलब क्या है? तो frequency 1 is greater than frequency 2. So therefore observations will be like this. Okay, see here. Okay, so this is the one type that is called intensity I1. I1 equal to I2. Therefore Vs1, Vs2, or this is stopping potential. Okay, so this is frequency. Okay, so this is the effect of intensity on photoelectric current, keeping intensity same but different frequency. Okay, so यहाँ पे जितना minimum frequency है, so that frequency it is independent of intensity. Okay, so that's why from 2, okay, it is also clear that potential, stopping potential is dependence on frequency. Okay. So therefore the photocurrent versus voltage. So keeping here frequency is same, f is same. Okay, so वहाँ पे है photocurrent. So here intensity is same. Okay, so intensity is same. So यहाँ पे जो है frequency is same, intensity is same. तो frequency is same but different intensity. Intensity is same, different frequency. So for example, f1 is greater than f2 like this. So we will have this graph. From 1 and 2, we have stopping potential is dependent on frequency. So जो stopping potential रहता है वो किसके ऊपर डिपेंड रहता है? Frequency के ऊपर डिपेंड रहता है. So this is Vs1, Vs2 we can say, but it is not dependent on intensity. Okay, so only it is dependent on only frequency. So जो किसके ऊपर डिपेंड रहेगा? Frequency, but it is independent only. So does not depend on intensity. So इस किसके ऊपर डिपेंड नहीं करेगा वो? Intensity के ऊपर. Hence maximum kinetic energy. Okay, तो stopping potential अंदर हम क्या लिख सकते हैं अभी? Stopping potential it stops. यानी कि stopping potential means it stops. Okay, maximum kinetic energy electrons. Okay, it stops maximum kinetic energy electrons. Maximum kinetic energy of electrons. So therefore kinetic energy of K equal to EVS. Okay, so for different purpose, if you study here the graph for kinetic energy versus potential, you have different potentials for different states for metal. Okay, so we have the graph for frequency versus stopping potential. This is frequency, मतलब it depends on only frequency, no. So frequency के ऊपर डिपेंड करता है, मतलब Vs1, Vs2. Okay, तो frequency versus photocurrent यहाँ पे it depends on stopping potential versus frequency Vs1. Okay, so we call it as frequency versus Vs. Okay, so this is graph for stopping potential and kinetic energy. Okay, it depends on frequency, does not depend on intensity. These are the effect for experimental observations on photoelectric effect. So these observations further becomes your laws for